So welcome back to the another session of our data structure journey. So in this video, we are going to cover the queue implementation of all operation by help of the linked list. We are already completed the linked list with all operation, insertion in at any position, first position, last position, deletion also. Same concept here we have to use for the queue. So what are the operation of the queue? First one is the NQ where we are performing the insertion operation. Means we are inserting an element into the queue. Next one is the DQ. DQ is the deleting an element from the front end of the queue. Pick means we are only retrieving the information stored inside the front pointer without deleting the data. Next operation is the overflow where we are going to check whether queue is completely full or not. Last one is underflow means we are going to check whether the queue is empty or not. Queue is empty means there is no data present inside the queue. So let us understand whenever we are performing the queue operation by help of the linked list. So what is a linked list? Here what happened? All the information stored in a node format. So what is a queue? Queue is a list of element where, for example, this is the list of element where insertion can be done from one end and deletion done from the another end. So for example, this is our queue. So insertion and deletion are done from both. So this is the end where insertion is going to be, and this is the end where the deletion is going to be. Here we are inserting the data, here we are going to deleting the data. So that's why it is called as the fast come and fast serve, or fast in, fast out. The element is inserted into the queue is fast, is going to be deleted fast. So for example, I want to insert first 10. So what happened? This position we store the value 10, then 20. So rear, from the rear side, we are using the insertion. Now we want to delete an element. So delete means this element enter into the queue first, it's going to be delete. So deletion done from the front end and insertion is done from the rear. So insertion we called as the NQ operation. NQ operation means insert an element. DQ means we are going to delete an element. So now first question, how we can able to represent the data in a linked list? As we know, the linked list means consist of node. So here what happened? Nodes are present. So for example, these three elements we want to store. So first store the information part, like 20, 30. Now three node we store the data, but they are not connected. Linked list means all are connected. So whenever this node is created, for example, this is the address, this is the address of the node. So if I store the address, it is linked right now. So last node point to the null. So now this is our front pointer, this is our rear pointer. So in this way, we can able to represent the data present inside the queue in a linked list. For example, I want to insert one more node. So whenever we want to insert one more node, at the time what we have to do? We have to create the node, store the information, that node we make as a null, then we make a connection. This is the rear X we make as a this value. Then we point this node to this. So this is the insertion is over. Now NQ operation is same as the insert and node at the end of the linked list. So NQ you can make as a insert node at end of linked list. So this is the same as the end of linked list. For example, we want to delete. So deletion means the element insert is going to be deleted first. Which element is insert? That is the 10. So by front end we are using for the deletion. So for example, we have to delete this node right now. So deletion operation we call as the DQ. So now what happened? We have to delete. So if I make the front equal to front next, deletion is over. But before that, we have to print the value. So what we are making, we make that this temp is a pointer that points to the store the front value. So right now, both the temp as well as the front pointer point to the first node. Then what we make? We make the front pointer point to the next node. Now this is the front node. Then what happened? We print the value and delete the value. So deletion or DQ of Q is over. So here what happened? Whenever you go for deletion, so deletion is the from first position of the linked list. So DQ is same as the delete a node from begin of linked list. So this is the begin of the linked list. So this is the way we can able to implement the Q all operation by help of the linked list. Main operation NQ and DQ. So now one thing is that, so whenever we go for the linked list, this node, this pointer we call as the start, this pointer we call as the last. So first right now becomes to the front, last becomes to the rear. So initialization means whenever there is no data, so what we have to make? We have to make the front equal to null and rear also we make as a null. Means there is no data initialization, means there is no data. So this two pointer we make as a null. So whenever we are creating the node, for example, this linked list we want to create right now, this the linked list of this element. So what happened? For example, we enter the value 10. Means we enter a value 10. We have to store in a queue. Right now, what happened? Our queue is empty. So we have to queue is empty means we have to check the front equal to null and rear equal to null. Then our queue is null. There is no element present inside the queue. Then what happened? You have to do? You have to simply create the node, store the data, make the next pointer as a null. So whenever we are inserting the first node to the queue, then what happened? We have to make the front as well as the rear. Right now, what happened? For example, this is the address is 100. Then what happened? This address also. Now this is 100. This is 100. Both pointer. Next element we want to insert. So we create a node, store the value 20. Then this one is the null. This thing, minimum thing we have to do. Then we have to check whether front equal to null. No, if front is not equal to null means data is already present. So here what happened? Simple, we have to make the rear next. So this is the, right now this one point to this value. So now what we have to do? We have to make rear is 100 next, this one is store the 200 value. So it make a connection to this one. After that we have to make this rear equal to this value. So what we have to do? We have to store the 200 value. If we store the 200 value, rear point to this one. So this is the way we can perform the NQ operation of the queue by help of the linked list. So this is the way we can able to. Again, we have to, whenever we are going to delete, so what happened? We have to make a temp pointer. For example, I created temp store the value of 100. Now what happened is store the 100 value. Then we make the front equal to front next. So what is the front? Front is 100. Right now we make the front value equal to front next to 100. Now front points to this one. Then we print the percentage temp info, we print this value. Then what we have to do? We have to delete the value. So whenever we make the free means it will delete the memory occupied by this node. So now our deletion operation is over. So this is the way we can perform the NQ or DQ operation of Q by help of the linked list. So first function is that is operation is empty. If the front pointer is null, then it returns true. Means if we write a function that is the is empty function to check the linked list is empty or this the linked list implementation q is empty or not, then it is returns true. Otherwise, it returns false. Each full, there is no overflow condition arise because we are using the dynamic memory allocation. Sometimes it may happen that whenever you go for a memory allocation, at that time memory allocation, but it is very rare to rarest chances. Then NQ operation. So NQ algorithms is allocate the memory for new data by help of the malloc function. If the memory allocation is unsuccessful, then print the error message and exit. If the memory allocation is successful, then store the data, the new node, and on to the next node. So if front pointer is null, once we make the store the data and null, then we have to make the check the whether it's a new node or not. So if the queue is empty, so then we have to make the first pointer as a new pointer as a front as well as rear. Otherwise, means data is already present, then make the rear pointer to the next node. This is for the DQ. Check if the queue is empty by checking the front pointer value as a null, or we can call the function. If the queue is not empty, then store the front value into the temporary pointer and print the data in the for deleting. Now make the front pointer to the next node and release the memory occupied by temporary data pointer and deletion is successful. Pick algorithm. If the queue is empty, we have to check. Otherwise, we have to generate the underflow condition. Otherwise, what happens? We have to retry from the front pointer without removing the queue. First, we have to define the header file as to. So as we are going to implementation in a linked list, so first we have to define the structure. So make the structure node. So there are two information we want. First in the integer data, then next is the pointer. So we need two pointer to store the value as a null. First pointer points to the first node of the linked list. Second pointer points to the last node. That is for here we have to use. So we make the node that is front store the value of null. Next we have to declare that is equal to null. So two pointer we declare front as well as the rear. Then we have to write down the isEmpty function. IsEmpty function returns the true or false. So we make the return value as a integer. If front equal to null means there is no data, it return 1, else next function we have to go for the enqueue. Enqueue means we have to insert an element into the queue because there is direct we have to go, there is no useful condition, so we have to use direct. So in for simplicity, I make the enqueue function as a very simple. The function does not take any parameter, does not return any value. So this is the algorithm. So before going to details, first we have to allocate the memory. So what is the step one? Allocate the memory for the new node. So we have to write down, for example, the new node is the current node is equal to, you have to first allocate the memory by help of the malloc function. We don't know how much memory is required, that's why we use the size of operator. Then we have to check whether memory allocation is done or not. So for that we have to check if there is very rare chances the memory allocation is not done. else means memory allocation is done. If the memory allocation is done successful, then store the new node data and data into the new node and pointer. So till now we are not write down to read a value. So we have to write down printf enter element into the queue. So here we are entering the value inside the queue. Then we have to go for scanf function, %d. For example, we store in the variable that is n. So we have to declare also n as an integer n. Once we store the value, then what is the step? Step is written if the memory is successful, then store the data into the new node. So new node is the current data which value we have to store n value, then current next equal to null. So this step is over. This step is we are already completed. Now we have to go to the last step. If front is null means we want to check whether there is any element. If the queue is empty, then we have to make the newly created node or newly created node as a front. So if front equal to null, then what we have to do? We have to make the front equal to here equal to current node. Simple. Then else means already element present inside the queue. If it is already present, then what we have to make? We have to make the rear next is equal to current node. We make then make the new node as a rear. So we make the connection, make the new pointer as a rear of the queue. So this is the NQ. Then we have to go for the DQ. DQ means deleting an element. So void DQ. So this is the function we have to. So this is the algorithm to implement the DQ operation. Check if the queue is empty by check pointing to the null value. We are already declared a function that is the is empty. We have to call it. If is empty is true. If return true means queue is empty, so we have to write down printf new line queue is underflow deletion cannot possible. Else means data is present, we have to delete. If queue is not empty, then store the front pointer into the temp pointer. Okay, so we have to declare another pointer. So that is temp. And which value we have to store? We have to store the front pointer value. We have to store the front pointer. Then we have to print which data is going to be deleted. Printf %d is the deleted. Then once we print the value, then we have to make the front equal to front. Next, then we have to release the memory. So this is our Deletion function is over. So this is our deletion function is over. Once deletion is over, then one more thing we have to do, that is the display function. We have to write down the display. If we want to display all the element present inside the queue, so void display. So we have to print all the value. So we have to declare a structure. We have to store the front value first. Then we have print the value now. So we have to write down. Then while temp is not equal to null. Same thing when the way we are printing in the linked list. The start we make here the front. So while temp is not equal to null, so we have to print the value, printf percentage one tab to temp data. We have to print the information part. Information part we store where the data, yes, data. So we have to write down the data, then temp is equal to temp next. So our display function is over. Before that, this is for print, but before that we have to check whether the queue is empty or not. If the queue is empty, we cannot print. So for that, here we have to check. If is empty is true, then we have to printf queue is empty. Queue is empty. Else, then only we have to print the value. So else store the value, then we have to printing the value. Then we have to go to our main function. So this is the main function, integer main. So here, if you have to go for the menu type program, we have to define the choice also. Choice. Then do. So printf one for NQ operation. Two for VQ. V for pick. We are not write down pick function till now. Then fourth for display. Fifth for exit. So whatever we enter after that, we have to scan F. %D. So let us complete the pick function. We are till now we are not done the pick function. So whenever we go for pick function means it will display the topmost element present inside the queue. So here from the front end, so first we have to check whether data is present or not. So is empty. If it is true, then our queue is empty. So what we have to write down? We have to simple printf and data can be read. Else means the data is present. So what we have to print? So whatever we want, we have to just write down. So this is the front data. So this is our big function. Then we have to go for our main program. Main function, once we enter the choice, we have to put into the switch case, choice, whatever choice, case one. Case one is enqueue. So what is the enqueue function? We have to then dequeue. This is our exit point. Then we have to go for break. Otherwise, default. So default means we have to print that invalid option. So this is our switch case is over. Then we have to write down the while. This is our do while. The while choice is not equal to. Last video we make the greater than or less than. That's why we got the error message. Okay. So let us compile the program. If any error, we have to rectify. Size of. Okay. We are using the malloc function, but we are not include the header file. Okay. Okay, this is printf function. Yes. Semicolon. Each and every statement should be ended with a semicolon. Display. Function name is mismatch. That's why I try to copy. Okay, now one is NQ. Enter the data 11, 22, 4 is for display. Yes, it is showing 11 and 22. Then we go for the delete. First element is the 11, it is going to delete. Then we go for again deletion. It will 22 is deleted. Okay. Again I go for deletion. Q is underflow. Deletion cannot possible. Okay. Once again I go for, I enter the value 11, then 2, 2, 2. Then again I enter 3. Now I have to go for pick. So topmost element is the 11 because we enter the value. Here pick is Q elements are 11, 22, 33. So it is pick. So whenever it prints the value, if we want to clear the screen, then what we have to do? So here you can write down the clear screen, clear screen, clear screen. So each and every operation, it will clear the screen and print the value. So this is our complete program. We are already done and we are already got the correct answer. So hope you are able to understand the concept thoroughly. If you have any doubts, any point, you can write down in the comment section. I will try to definitely reply. And if more queries, I will make another video. And to understand this operation, we require two things, that is the insertion into the last position and deletion a node from the first position. I also put the in description section the link of this video. I have already covered at time of the link list. So you can go to and refer that. Also overview of the queue I have also put in the description section so that it will be easy for all of you to do the programming part. If you know the concept, then it will be easy. Thanks for watching the video. Please subscribe the channel.